We've reached a very special part of the course. So far, we've learned and or not. We've learned all these filter techniques. We've learned about the different values and how filtering actually happens. And the fact that we need a truthful or a false assumption in order to get the filter to work. Now, we also just learned about null and how null can throw a wrench into all of this, because null is equal to null. Well, in SQL, we have something special called three-valued logic. Now, what is that, you ask? Well, besides true and false, the result of logical expressions can also be unknown. It can be null. That's what we call three-valued logic. In most programming languages, unknown would often result in false. That would make sense, right? If you don't know something, it must be false. Well, in SQL, there is a slightly different approach. And we saw that when we looked at null being null. When you select null is equal to null, when you do that comparison, is null equal to null? Well, that's going to return you null. It doesn't return you true. It doesn't return you false. So, three-valued logic works like this. On the left-hand side, we have statements that can be true. And on the right-hand side, we have all the statements that can be false. And then here in the middle, there is this intersection where, depending on what we do, a value could be null. And if it's null and we compare against it in some logical fashion, it may return us null. It may return us unknown. And that throws a wrench into our entire query, to be honest, because now it isn't going to work. And that is a bad thing. So three-valued logic means that each expression can have three different outcomes. An expression can be true, an expression can be false, or an expression can be null. And we want to avoid null as much as possible. That's why we looked at null coalescing. That's why we learned the is keyword. Null is a bad thing. Not always. It's good to have nulls around in your data type if you're expanding, and we talked about all of these different edge case scenarios. But speaking frankly, null can cause unwanted behavior. So, in three-valued logic, the SQL null is a value, and it could be anything. Null doesn't mean it's nothing. It just means we don't know what it is. So, when we look at it conceptually, when we look at a null conceptually, it just means it could be anything. SQL isn't going to determine what it is for you. It's not going to say it's true or it's false. It's going to say, I don't know. This could be anything. And that's why we call it three-valued logic. Now, we also looked at null, and we said nothing equals null, not even null. Each null could be different. So if null is not equal to null, that means an unknown value is not equal to an unknown value. Null is not equal to null. Null equals null is not true, not false, it is null. SQL will reject that statement. It will say, I don't know this. And that is what is important here. To understand that with that three-valued logic, you have three different streams of outcome. When you do a filter, you can say, each statement that is true is going to return me a result. Each statement that is false is not. And each statement that is null is going to return null because nothing equals null. Not even null. That is why we use the is null check. When we did null is equal to null, we got null back. So SQL gave us this special operator, is null. And that is what is telling us, is this true or is this false? Because null is unknown, we need a special operator in order to tell us, hey, am I operating against nulls here? Are there nulls here? Is there a possibility of anything being null in this data set? So the is null check is important, is of vital importance when working with values that can be null. So let's look at some of those. Over here on the right-hand side, you can see I tried to elaborate on what the statement below is going to be. So we say null equal to 1 or 1 equal to 1. We're going to look at some tricky scenarios about three-valued logic. So we know that null is not equal to 1. So that's going to return us not false. No, it's going to return us null. Okay, so we know this part is going to return us null. And then we say or. 1 equal to 1. Oh, well, that's a normal expression. That's true, right? Yeah, that's true. 1 equal to 1, true. Okay, so where is the tricky part in this? Well, as you can see, I highlighted the green part. And by highlighting the green part, what I'm saying is this statement, if you did this in a where clause, it's going to be true. Now, why is that? Now, think back to our or statement. Remember when I told you when you implement an or, you're basically starting a separate tree or a separate filter? Not in actuality, but conceptually. It's a different node you're going down, a different flow, a different side of the river where you're checking something else. So when we say null equal to 1, we know that's going to return us null, and that's not going to help anyone. But because we have the or statement here, and because we're saying or 1 equal to 1, well, then the whole expression becomes true, because one of the sides of the expression, not the left side, but the right side, is true. Or says, well, if one of these is true, all of it must be true. Because of that fact that the or does that, all of it is true. Okay, so that makes sense. We will still filter on 1 is equal to 1 because of the fact that the or works that way. Now let's look at another scenario. Well, here you can see I highlighted the null section. Why is that? Well, null is equal to 1 returns us null. And 0 is equal to 1 is false. It's not equal to 1. So why am I returning null here? Well, like we said, or is this or this being true or false makes either side true or false. But now we're using and, which is inclusive. It's this and this need to be true in order for it to be true. This and this need to be false in order for it to be false. Well, null and false equals null, because null is always going to give you back nulls in an inclusive operation as and. There is no result set. Nothing will come back of this. All right, so we're getting the flow here. Null can be a tricky thing. Now let's look at something a bit more elaborate. Select column from table where column is equal to null. We already kind of looked at this during null coalescing and is null and learning about the is keyword. And we know that that's going to return us the null section because null is always unknown. So this is going to reject all of the results because null is not even equal to null. All right, so what if we did select column from table where column is null? Well, we learned this. Is null checks for unknowns, so it's going to be true. So we're going to get results back if it is in fact an unknown value of the unknown type. Are you starting to see the nuance difference between the equal sign and the is keyword? That is what we're trying to hammer in here. This is how nulls work in SQL. So now let's get into some real strange scenarios, because the previous ones, although I called them strange, we basically all already knew what was going to happen because we looked at null coalescing and we understand how nulls work. But here, select column from table where column equal to null or not column equal to null. Well, what would this return? Pause the video here and think about it. Well, the parentheses are here to throw you off because we learned that parentheses give us the ability to have something execute first. We know that column equal to null is null or is either this or this. Now, not column equals null. Well, column equals null is null, so not null is still going to return null. So consequently, all rows will be rejected. Nothing is going to be returned. Here's the next strange scenario. What would this return? Well, here we're using the is keyword. So is null is not null. So we're saying where it is null or it isn't null. In this case, because we're using is null, we're saying if it is null or it isn't null, return us the data set. So what would this return? Pause the video and think about it real quick. This, in essence, is a trick question nothing will be rejected. What do I mean by that? Well, we're filtering on what is null or what isn't null. So everything will be returned, the entire data set. Let's look at that real quick. Over here, I put together a query. Select star from student where age is null or age isn't null. So let's remove that where clause and let's see what data we have here. So we can see we have student 1, 2, 3, 4, 5. And when we implement the where age is null or age is not null, let's see what happens when we run that. So when we run that back, we still have 1 to 5. Huh. Okay. Let's just verify our hypothesis here. And if we run that back with is null, we're getting back 1 student. Okay. So it stands to reason that we are getting everything back that we wanted to. So let's take a quick look at our previous one. Let's say not equal to, and let's see it reject everything. No results to be displayed. See, the tricky part here is null is equal to null. So when you think about it conceptually, when you put these where clauses together, it can become quite tricky. I put the parentheses in, I put the or statement in to kind of give you a curveball. And as you can see, the equal sign with null does not work, but we all already knew that because we are masters of the is keyword. Now what we want to remember and what we want to stick with us is that SQL differs from many programming languages, being that it has that 3-valued logic system, being true, false, or null. And null is that tricky little thing. That thing that you may think won't hurt your query results, won't hurt your filters, but can do unknown things. It can strip things from your results. It can do weird things if you're doing calculations. You have to be careful with nulls. But the most important thing to keep in mind here is that we know that SQL has that 3-valued logic system, being that it can have true, have false, and have null.